So the thing is that uh, so if the problem that we explain, the you know tower of Hanoi, right? The problem tower of Hanoi, and I am explaining it with with the help of recursive versions. This is the recursive versions. So what we know, that the tower of Hanoi problem is to move bricks from one pillar to another. The problem is nothing but you have to move you know bricks from one pillar to another using a temporary pillar using a temporary pillar. That is the problem. So the thing is that, of course, there are two conditions. There are two conditions for the game. The first conditions, we can move only one disc. You can move only one disc from one pillar to another pillar at a time. And the second condition is that the larger discs you know cannot be placed on smaller discs, right? So say for when the number of discs is equals to 1, what I am writing, that means this is the corresponding initial position. The disc is there. This is a pillar A, this is pillar B, this is a pillar C, and this is the disc. This is the initial position. This is the initial position, and the final position, what we can say, that means if this is AB and this is C, I have to move the disc at that particular position. This is the final positions, right? So you don't have to graphically show this. What the output of your program, the output I want to show that move the disc from pillar A to pillar C. I want that. That means when the n equals to 1, the output should be like that. That moves the disc from pillar A to pillar C. Now say for n equals to 2. If n equals to 2, then if this is A, this is B, this is C, say there are two discs, right? These are two discs. So the thing is that the final positions, that I have to go to the final position, but before that, if this is a initial position, then what you have to first do, that means if this is A, this is B, this is C, then if this is a disc, I have to move this disc 2 right there. That means if this is a disc 1, this is disc 2, disc 1 is there, disc 2 will be moved there. That means I am moving like that from A to B, right? And then then what will happen, that disc that will be there, disc 2 will be there, and disc 1 will be that is a big disc that will be moved to the C. That means what will happen, the output should be like that. I am moving A to C, and then what I am doing, if this is A, this is B, this is C, then this number of discs, this is 1, and then we can place 2. That means the output should be B to C. That means the thing is output, that you have to show that we are moving disc 1 from you are not concentrating on the pillar, right? That you are not graphically show this. You have to show this the process. That means when the user will give n equals to 2, the output should be like that. The disc 1 is moving from pillar A to B, right, and then move disk 2 from pillar A to C, like that, and in this is a move disk 1 from pillar B to C. That should be the output if the user will give you know the value n equals to 2. So now if we say that n equals to 3, if the user will give n equals to 3, that means what will happen? The thing is that this is the 3 disks, say this is 1, 2 and 3, say this is A, this is B and this is C, then what will happen in the second step? What we can do, this disks 1 and 2 will be there, and I can place the disk number 3 there. That means we are moving A to C first step. This is A, this is B in the C. In the second step, what we can say, that means if this is A, this is B and this is C, I am moving from A to B. That means this is a number 2 disks, this is one number of disks, this is two number of disks and this is a 3 number disks. So we are moving from A to B, and then what will happen, this is disk number 1. What we can do, 3 number of disks is small in size, so I can move like that. This is 2 and this is 3, so I am moving like that from C to B, right? From C to B I am moving this, and in fourth number of step, what we can do, if this is A, this is B, so the disks from A we can move it to C. So in B there is disk number 2 and disk number 3, and in C there is a disk number 1. So I am moving from A to C. In that particular case, you can do like that. That means if this is A and B, this is B, just number of these 3 disks that will be placed there, that 2 will be there and 1 is already been placed. So what I am doing, from B we are moving to A, and then we can say like that, if this is A, this is B, this is C. So the disk 2, that means from B we are moving to C, so that means this is 1 and this is 2, and that is the disk number 3. So in the last step we are moving from A to C, right? If this is A to C, A, this is B, this is C, then this is the disk number 1, this is disk number 2 and this is disk number 3. So that is the output. So what I actually want as an output, A to C, A to B, C to B, A to C, these steps that you have to show in the output, right? So that means the output should be like that. That means move disk 1 from pillar A to C. It should be like that, and that will take 7 steps. You have to print this 7 step, and then finally you are reaching the output, right? I am just showing you for n equals to 1 to n equals to 2 and n equals to 3. So from this, what we can observe, that first we have to move n minus 1 disks, right? In that particular case you will show that first we have to move n number n, because we are first moving from A to C and A to B, right? So that means if there are 3 disks, that means we are moving first 2 disks to other place, and then this particular disks will be placed, this, when these 2 disks will be moved in temporary, and then you are moving this into the C, right? So what you are doing, the thing is, the summarize, if we can summarize the thing, that means what we can say, that we are moving the upper n minus 1 disks from A to B, using C as a temporary pillar, right? And this is the first thing we have to do. And second, the move nth disk, that is the nth disk, from A to C, and then again we are moving we are moving the n minus 1 disk, that will be n minus 1 disk from B to C using A as the temporary pillar, right? Temporary pillar that we actually did. So that means what I am saying, that you have to write a function, say tower of Hanoi function, tower of Hanoi function, and there is number of disks, there is a source, there is a temporary, and there is a destinations, right? And the thing is that what you are doing, you are moving the disk 1, right? What I am doing, I am just move the disk 1 from source to destinations, right? I have to move disk 1 from source to destination if n equals to 1. And if not, then what will happen? I have to call the function again. You have to call the function n minus 1 times, and you are now moving. What I am moving, the upper n minus 1 disk from A to B. That means B is actually used as a temporary, but in that particular case B is the destinations, right? B is the destination because you are moving the disk from A to B. That means B is treated as a destination. So what we can say, we are calling the function from source to destination because temporary is now used as a destination, right? B is a temporary and this is now used as a destination, and this temporary, that should be C, that means actual destinations, is now used as a temporary. So we can call the recursive functions like that. And if we want to say that, and again what we have to do, again you have to move the nth disk from source to destinations. So in that particular case I am calling the same function, and the thing is that this B, you are moving the disk from B to C. What is B? B is temporary, but it is now used as a source, right? And C is used as a destination. So what we can say, that source is now temporary, right? And destination is now source, that is also another thing, and the destinations remain as is. So you are calling the same functions, right? You are calling the same function because A can be used as a pillar, right? So that would be the thing that you should do. That means you have to write a program, right? That means this is the functions that you have to call the tower of Hanoi for 2 times. That means if we just write the function in C, that means what will happen, this is this is tower of Hanoi functions. I am writing integer index, and I am writing character because this is the pillar A, this is the pillar B, and this is the pillar C, destination. Now what will happen if the number of disks is equals to 1, then what you want to print, I want to print that I am moving the disk 1 or 2, whatever disk 1, from A to C. That means this character I am writing like that to C, and in place of %d I am printing the number of disk name. If this is disk 1, then disk 1, and this %c we are printing the source, that means A, and this is the destination, that means B. And just I am just writing return because recursive call, there should be a base condition or anchor conditions, that means from where the recursion will end. And then what I am saying, that I am calling the same function, that means I am calling tower of this Hanoi function again, where we are calling it index minus 1. I am just writing same thing, source, that should be destinations, that means the temporary is now destinations, and the destination should be temporary, like that. And we are printing the same thing, like that. I am printing like that. That means I am moving disk %d from %c to %c, and I am printing like that index source destinations, right? And the thing is that source and destinations, right? That, and the thing is that in that particular case again we have to call the function, call the function, this is index minus 1, say this is a temporary, this is source, and this is destinations, and I am just writing return 0. I am just writing this 2, that's all. Now if we do it like that, that means if we say how we can do it, whether it will be understandable or not, let's see. Say I'm not writing whole thing, but the thing is that, say I am writing this, I am just calling this function from main. Say there are 4 disks, a is the source, if you say, or you can say 5, it will be better. I am calling the function say 5, and this is the source, this is a temporary, and this is the destinations, right? So the thing is that if the number of disks is 1, so what will happen, it will directly print a to c, right? But that will be called recursions like that. That means how it will call recursion, it will call you know this type of recursions, you know it is called 2 times, that means 4 a c b, because we are changing this, we are calling the recursion like that. N minus, this is the source, source is a, and destinations, destination is c, and temp is equals to b. And as well as it will call this recursions, that means I am writing this, this is the recursion, this is hf, right? Hf, tower of Hanoi function, and you are calling, this is 4, and temp is b, and source is a, and destination is c, right? So I am calling this function again, this call the function, say tower of Hanoi function, again this is called like that 3 a, because you are calling 2 times, that means source is a, here the destination that is equals to c. So you are calling a, b, and c, because this is the destination, so destination temporary, that should be destination. You are calling the same, that means again you have to call, write that tower of Hanoi function, this 2 a c b, again you are called the tower of Hanoi, tower of Hanoi function, say 1 a b c, and then if you evaluate it, then it will print a to c. So it will be evaluated like that, it will be evaluated like that, right? Because in that particular case, if it go directly, it will print a to c, and from this you are again calling this function 1 c a b, and it will print like c to b, and directly it can print like a to b. So if we draw this tree like that, you will say in that particular site you will get all the steps, right? You will get all the steps, that is it. It is not possible to write all the steps, right? That means if we can write this all the steps, then
মানে স্যার 5টা ডিস্ক থাকলে এরকম ভাবে আর কি হবে?
evaluated হবে, 3টে ডিস্ক থাকলে
আচ্ছা।
রিকার্সিভ কল ওইভাবে হবে, রাইট? বাট দ্য রিকার্সিভ কল কিভাবে হবে, রাইট? দ্যাট যদি 3টে ডিস্ক থাকে, আই এম জাস্ট সিইং ইউ দ্যাট what is the thing, that means there are 3 disks, this is tower of Hanoi functions, say 3 disks,
স্যার
you
স্যার
know
দুটো দিয়ে স্যার দুটো দিয়ে করুন স্যার, তাহলে একটু
abc আমি 3টে দিয়ে দেখাচ্ছি. So what will happen, this will call the recursive function 2 times, right? One is tower of Hanoi functions, you are calling 2, this is a, this is c, this is b, because what I am calling here, right? This is a source, right? Source is a, destination is c, temp is b, right? And you are calling again the function, that means temp is b, source is a, and destination is c, right? So we are calling 2 BAC and ACB, right? So you just see that I am calling this 2 ACB, and tower of Hanoi function 2, this is BAC, right? Again that will call 2, that is tower of Hanoi functions 1, but in that case that is now become source, because I am writing the functions like that. I am writing
স্যার
the
এই স্টেপটা একটু বলবেন, ওই টাওয়ার অফ হ্যানয় এর এই 2ACB, এটা তো সোর্স,
হ্যাঁ
বিটা টেম্পোরারি, আর
yes
সিটা ডেস্টিনেশন, তারপরে এনটা একটা কমে গেল, নাম্বার অফ ডেজ 2
হ্যাঁ, তো
হলো।
তুমি তো এইভাবে কল করেছো ফাংশনটাকে, আমি তো দুটো ফাংশন এইভাবে রিকারশন ফাংশন কল করছি, রাইট? দেখো এখানে সোর্স, ডেস্টিনেশন, টেম্প, তাই তো? তার মানে চেঞ্জ হয়ে
হ্যাঁ হ্যাঁ
যাচ্ছে না? সোর্সটা তো আমার তো নর্মালি সোর্সটা ছিল এ, রাইট? আর তোমার
হ্যাঁ
হচ্ছে
হ্যাঁ
টেম্পোরারি ছিল বি আর ডেস্টিনেশন ছিল সি। কিন্তু যখন তুমি সেকেন্ড টাইম কল
হ্যাঁ।
করছো তখন তো চেঞ্জ হয়ে যাচ্ছে অর্ডারটা, তাই জন্য এসিবি লিখছি।
তখন আর কি, যেহেতু প্রথমটা চলে যাচ্ছে বিতে, সেই জন্য।
হ্যাঁ, মানে জাস্ট আমি অর্ডারটা চেঞ্জ করে দিচ্ছি, সোর্সটা চলে
আচ্ছা
যাচ্ছে এতে আর যেটা ডেস্টিনেশন ছিল সেটা এখন মিডিলে চলে আসছে আর টেম্পটা এখন লাস্টে চলে যাচ্ছে, যেটা আমি দেখালাম তোমার। আর আরেকবার কল করছি যখন টেম্পটা প্রথমে আসছে, সোর্সটা এখানে আসছে, ডেস্টিনেশনটা এখানে আসছে। আমি জাস্ট এইগুলোকে লিখছি এইভাবে, দেখো বুঝতে পারলে কিনা? বিকজ
স্যার এই পিলারগুলোকে
হুম
বলছি এই পিলারগুলোকে সার্টেন এরকম ভাবে না বলে যে এটা এই সোর্স হবে আর এটা ডেস্টিনেশন আর এটা টেম্পোরারি হবে, এটা না ভেবে যদি আমরা এরকম ভাবে ভাবি যে যেখান থেকে আমরা ওই লিস্টটাকে নিচ্ছি আর যেখানে বসাচ্ছি, প্রথমটা হচ্ছে সোর্স আর পরেরটা হচ্ছে ডেস্টিনেশন, এইভাবে জেনারেল ভাবে যদি ভাবি তাহলে এটা করতে মনে হচ্ছে বেশি সুবিধা হবে।
না, সেটা তুমি করতে পারবে কিনা সেটা তুমি করে আগে দেখতে হবে, সেটা তুমি
হুম।
করতে পারবে কিনা সেটা আগে দেখতে হবে, যে করতে তুমি তুমি নিজের মতো করে আগে ম্যাথামেটিক্যাল ডিজাইন করতে পারছো কিনা সেটা আগে প্রথমে দেখতে হবে, রাইট? সো দ্য থিং
আচ্ছা
ইজ
স্যার,
দ্যাট
প্রথম একদম একদম ছোট যেটা ডিস ছিল সেইটা যেহেতু সিতে প্রথমে মুভ হলো, তখন সিটাতে তো অলরেডি আছে, তারপরে যখন সেকেন্ডেরটা মুভ হচ্ছে তখন আর কি আমি ওটা বিটা ডেস্টিনেশন হচ্ছে,
হুম
সেই হিসেবে বিটা ওখানে লাস্টে
হুম
রয়েছে।
হুম 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 সো
আচ্ছা
ইফ ইফ
ঠিক আছে।
হ্যাঁ, যদি তুমি এইভাবে হাতে করে দেখো, ইউ ইউ ডু দ্য ক্যালকুলেশনস লাইক দ্যাট, তার মানে উই আর কলিং দিস লাইক দ্যাট CAB, and directly there are three call, that means it will give you from A to B, because this is the source and this is the destination. That will give you A to C, and that will give you, C to B. And again you are calling the functions like that, that means tower of Hanoi function, that is one, this is BCA, and the thing is that this is also tower of Hanoi function one, this is ABC. And if you can do it, that will print you, from B to C, right? That will print you from B to A, and that will print you from A to C, right? Because all conditions are mature when n equals to 1. So that is the corresponding 1 2 3 4 5 6 and
স্যার এই
9.
দুই ভাবেই করা যাবে তাই তো?
হ্যাঁ,
দুভাবে করা যাবে।
this is B to A, B to C and A to C, and like that. So that will the procedure, you can say a procedure if we can maintain, then we can print this, right? আমরা এইভাবে প্রিন্ট করে এই জিনিসটাকে করতে পারি।